Hi everybody, and welcome to our last chapter, 24, on capital budgeting and investment analysis. While we won't be testing this on the last exam, the final exam, this is really important information for you as MBA students. So I thought it was appropriate that we go through this a little bit, and of course there's some homework associated with this chapter as well. So to start this off, let's look at some concepts of the time value of money. Okay, first of all, pretty easy here. We have the future value of an amount. There's 4 concepts we're going to be going through. Future value of an amount, future value of an annuity, present value of an amount, and present value of an annuity. So we'll take a look at all those, and that will be a nice introduction to this chapter. Okay, so I put $1,000 in the bank at 10% interest rate. What's its value in 5 years? Okay, how would we do that? Well, we would set up this little metrics. I call this Steve's way. There's other ways to calculate this, but I want you to see how it's done manually. First of all, we start with period 0. Period 0 is right now. Period 1 in this case is 1 year from now, 2 years, 3 years, 4 years, 5 years from now. And then always in period 0, the factor, as I call it, is 1. And then we multiply the previous cell times 1 plus this interest rate at 10% here. So that's going to be 10%. And then we multiply the next cell by the previous cell times 1 plus the interest rate, etc. down. So that's a compounding factor, as you see. Now, as I look at this, no surprise to anybody, how much is $1,000 worth at 10% a year 1 year from now? Well, pretty easy. We get our $1,000 plus 10% of that $1,000, and that's $1,100. However, in year 2, we get our $1,000 plus the $100 from year 1 and the $100 from year 2, but it says $1,210 here. That's because this $100 in year 1 that we earned as interest is also earning interest. So there's where we get the compounding. This factor is a compounding factor, and to calculate these numbers, we multiply the original $1,000 times the factor. So for year 5, how much is that $1,000 worth? It's worth $1,610.51 compounded. Okay, that's the future value of an amount. You can use that personally as well for figuring out how much your 401k will drive up to over the years, and lots of great applications for this. Not to mention purchasing a car and some of these other things that we'll use derivatives of this calculation for. Okay, so now, present value of an amount. Here it's a little bit different. Here, the present value is what that money in the future is worth in today. So here, at the end of 5 years, we are expecting to have $1,610.51 in the bank, and the bank is expected to pay us 10% per year on our money. What is the present value of that amount? Well, the setup is exactly the same. We set these factors up, and by the way, I have published this in the modules, so you'll have this to review. This particular file is called Basic Time Value of Money Calculations. And so we calculate these factors, but for present value, we divide. So we divide that $1,610.51 by the factor. Now, you will also see in the book present value tables. They are similar to my factors here, and I'll do them very quickly for you. If you take 1 and you divide that by my factor here, and make it a little bigger, this is what you're going to see in the present value tables, these numbers. And if you use what's in the book, instead of dividing for present value, you would multiply these book factors times, in this case, $1,610.51. And you'll get the same answer. My way is a shade more accurate because there's no rounding. Even though it looks like I've rounded this to 5 decimal points, I have not. So you can see that it will be more accurate than putting just the book factors in and multiplying. Okay, next we're going to do a future value. This time it's a future value of an annuity. And in this case, we put $1,000 in the bank in each of the 5 consecutive years at a 10% interest rate. And what is the value of that annuity in 5 years? Well, the setup, shockingly, is exactly the same. We set up our factors here, but this time we actually use the period Z0 factor. And so that 1 times 1,000 is 1,000, and then 1,112.10, etc. And that says that this is going to be worth $6,105.10 if we use that way. And there is a factor that you will find also in the book, which says 6.10510, and that's just the sum of all these factors here. And you'll find that as I say, in the book in the present value tables. Okay, and then lastly, we have the present value of an annuity. The present value annuity says we're going to put $1,000 in the bank in the bank each year for 5 consecutive years at a 10% interest rate per year. What's the present value of that annuity? Well, in this case, the present value of that annuity, we're going to start with the period 1 this time, and the present value is going to be, if we put $5,000 in there, the present value of that's going to be $3,790.79. Okay, for discounting, again, we divide. For compounding, we multiply using these factors. I also have some practice problems for those that are very interested to apply some of these principles. But I think it's important initially to understand these basics of the time value of money. Okay. All right then, let's get into the PowerPoint. Capital budgeting and investment analysis. Here, we're going to take a look at how we're going to evaluate capital investments in projects, something that I've done lots of times. And there's several techniques we're going to use. We're going to look at one of them is break-even time. Another one is payback period. Another is accounting rate of return. The most important are net present value and internal rates of return. And we'll get into that in some depth in this video. All right. Capital budgeting, then, is the process of analyzing alternative long-term investments and deciding which assets we want to acquire or sell. So what happens is that someone, even maybe you, submit a proposal, and then the capital budgeting committee evaluates that proposal and recommends approval or rejection. So how do they do that? And then they forward that on to the board of directors, who then approves that capital investments for the year. These tend to be the big dollar expenditures for the company. So they're looked at very carefully. And that's why they need MBAs, to be able to do that kind of work. All right, so capital budgeting decisions are usually the most difficult and risky decisions that managers make. And why are they risky? Well, because the outcome is uncertain. There's a large amount of money involved, and that investment usually requires a long-term commitment, several years usually. And the decision then is almost impossible to reverse. An example of that is you buy an automobile, for example. That automobile, once you buy it, it's a fixed cost. It's a sunk cost, and you're not going to get it back if you make a mistake. Okay, so first of all, in this case, they're showing a, looks like a lathe, something very familiar to me. And that's an initial investment. The last one I purchased was over $2 million. Okay, and then we use that lathe to make things. And we have sales, and we have expenses, and we generate net income, and we generate, more importantly, cash. And then once we've used up that machine, we usually get something for it in the way of salvage value. So that's sort of the cash flows from capital investment. And I should stay up front. When we're doing these analyses, we are using cash. Please don't get confused by that. We always use cash in and cash out to make our investment decisions. Okay, let's take a look at payback. This is pretty easy, I think, and how we would use it. Payback is the period of time that we expect to recover the initial investment. So the formula is pretty easy. We take our initial investment and divide it by our annual net cash, emphasize cash, flow. Naturally, the faster we can get our money back, the less risk there's going to be. Naturally, then we're going to prefer projects with shorter payback periods. Okay, so if we look at a payback period with equal cash flows, then it's the arithmetic, I think, is very easy. In this case, we had an initial investment of $16,000. We think we're going to make $4,000 of cash flow. You can see that here. Here's the income we expect to make, but that includes the depreciation on this machine. Depreciation is a non-cash expense. So they've removed it here in the cash flow calculation, and the cash we expect to generate per year is $4,000. So we expect that we'll pay this back in 4 years. Okay. Now, if we have unequal cash flows, then we need to do a cumulative cash flow column, which they show here. And we wait until that cumulative cash flow goes positive, and then we take this cash flow at $2,000 as a percentage of the year 5, $4,000. That's a half a year, and so this will pay back in 4.5 years. Okay, that looks like a good place for us to stop this video, and when we return, we'll take a look at the payback period in a little more depth. Until then, bye for now.